are you doing research at RIT? Are you working on research as well? So if so,
Yep.
what is your research and how does it impact the society?
I'll start with kind of my research, and then I'll try to see if it impacts society. But from a research point of view, like I would say, last year I got a fund from industrial entity. It's a company called Emirates Global Aluminium. It's one of the biggest aluminum producers in the world and exporters here in the UAE. And they have like this huge aluminum smelter. And over there, they have some issues with increasing the lifespan of, we call them ingot molds. So those are pretty much aluminum molds, okay? And there have been some issues with them prematurely failing, some cracks propagating faster than anticipated, and which results in kind of stopping production, okay, which is something for them really expensive. So mostly I would say last year I've been working on this project. It's a funded project. And the objective is to find ways around increasing the lifespan of molds in aluminum production. So there's quite a lot of material sciences in that project to understand the full issue with corrosion. The same mold, for instance, undergoes quite a lot of different heating patterns or heating cycles. So from pouring liquid aluminium at such high temperatures onto it, you can think about this as a thermal shock, which I had to model. From later on, it being cooled down such that it solidifies pretty fast. That's another thermal shock. Later down the road, it needs to be hammered to separate the mold from the cast itself. So that's also an impact load. So it was a pretty interesting research topic, and it's about to be over in the next few months. So that's one of the projects that I've been working on. It's pretty tied to industry. Some other projects I've been working on, they are research, but I would say they're not very much tied to industry. So they're pretty theoretical in that sense. Some of them have to do with a continuation of my PhD work, some topics that I'm still extending, having to do with stress functions and what have you. More recently, I've been collaborating with a colleague of mine at Masdar Institute. It's a research institute in Abu Dhabi. They offer PhD programs and master's programs over there. The topic is on how can we do kind of smart monitoring of PV and solar panels in smart cities. Mm-hmm. So the notion of smart cities is very new, especially in this region. Everybody's pushing for smarter cities, smart transportation, smart buildings, smart sensors, a smart home. So the word smart is being used everywhere. But there's a struggle when it comes to how do you monitor those systems. So for example, in my house, I have a solar panel, but how do I do smart monitoring on that? So I've been working on some kind of scheme on doing smart monitoring for solar panels. So those are, I would say, like some topics that I've been working on recently.
Okay. And so I have 3 follow-ups to the question, to the answer which you said. So the first one is smart monitoring. So what are the schemes that you use to monitor these smart systems?
I wouldn't say I'm very much the expert on the topic, but at the moment, like you would see, for instance, if we were going to talk about solar panels, if you have a certain field, and those are very common now, like having a solar farm or a solar field full of solar panels, doing monitoring on those is, I would say, easier than other applications simply because you know their location and they're sitting right next to each other. And usually those farms are either sponsored by some ministry of energy or some authority related to electricity. So they're usually technical people. Mm-hmm. So they would have, let's say, some sensing equipment to evaluate the efficiency of those panels, throughout the day. But the project that I'm working on is how can you do the same type of monitoring, but with those solar panels distributed over a certain city. So it's no longer concentrated within a small region. They could be scattered in this rooftop. that rooftop. They don't have a specific grid, just like any other city. And though the approach that we're working with right now is to do basically thermal imaging, okay, by utilizing some drones. So having thermal cameras installed on some drones, and taking thermal images at different times. And from the images, we can actually get some information about the efficiency of those solar panels. For example, if there's a certain lamination in a certain panel, if there's a small cell failure, if there's quite a lot of dust accumulating on the panel. So from the solar image, there's a lot of imaging techniques involved, but you can extract this kind of information and, maybe feed that information back to some authority to do the necessary, whether it's a maintenance or what have you.
Great, interesting stuff. Yeah. So another follow-up is, so when you said you are modeling, coming back to your first project, which is the mold analysis, when you said you're modeling the thermal loads and shock loads and impact loads, what are the tools that you use? So so it sounds complex. So is there one particular tool, or is it a combination of a computational model, analytical, and theoretical thing?
Yep. I would say it's in a way a combination. It's a combination of tools. So, for example, I'm using a few finite element packages to help me with the project. One of them being ANSYS. Mostly, I'm using ANSYS to model the hammering process itself. So after the liquid aluminium solidifies in a certain mold, it needs, in some cases, to be hammered, such that you get a separation from the solid aluminium from the original mold. And so I'm modeling that hammering process and its impact on the mold itself. So, and it's kind of like a fatigue. It's a low cycle fatigue process, because the same mold, well, it's kind of like on a conveyor belt, and it goes back, same process, gets hammered again, a few minutes later, hammered again, and so on. So it's kind of accumulation of impact stresses and loads on the structure. So for this one, I'm using ANSYS for the most part. For the thermal part, where I'm looking at the thermal shock or the thermal stresses induced by pouring the raw aluminium into the mold, I'm using a software called ProCast. It's kind of it's also a finite element package, but it's mostly tailored. It has the physics necessary to model solidification processes. So anytime you have a change of phase, so from a liquid to solid, solid to liquid, some finite element packages fail to give you the exact physics behind it. ProCast is one of those software packages that is tailored towards fabrication, casting, and so on. So I've been using that to look into what are the stresses and the residual stresses from every cycle of pouring raw aluminium into the mold itself. So I'm using a combination of things, and I always use MATLAB to kind of sometimes superpose results, sometimes to get a visual of the results, contour plots. So yeah, if you think about it, you end up using different softwares to get to the end product. With this project, I wouldn't say a lot of analytical work, but when it comes to knowing or understanding the physics behind those different processes, you have to know the analytical equations behind them.